那我要不稍微再等会儿，看到现在好像只有2个人。
这咋都起不来了，是不是？
星期五睡懒觉。
还不到周六、周末呢，周六周末再好好休息呗。我现在是周一到周五就是工作学习，然后呢，周六周天是基本上全玩，基本上不想太那个什么。毕竟加拿大的夏天也确实太短暂。
我们滑铁卢学生，
好像没有这个权利可以说对是吗？
真的，我周六周日我能挑一天不做事，我已经谢天谢地了。
哎呀，是啊，但是其实有时候想一想哈，你如果从励志的角度上来讲，其实人生你们最后的成功，不就是因为平常我这个别人都在玩，然后那个这个没什么事可干的时候，然后你们还在做事情嘛，对吧？然后所以你们比其他人更多一个机会啊。虽然我觉得滑铁卢的学生现在想想，其实也没有什么特别的，唯一特别的，我觉得就是 resilience 就是比较好，就是 persistence。啊，那 persistence resilience 就是真的是不懈努力。我现在真的理解到什么叫不懈努力了，就是真的是就像你说的，没有可谈的，可以每一天可放松的。
大家都是愤怒。
是啊，是啊，所以就是说，从这个角度上来讲，就是说，最后的成功其实是取决于什么呢？其实，我觉得现在你说人，你说有聪明的，有笨的，我觉得都没有笨的，都是其实现在的营养也好，什么的都挺聪明的。但是所不同的就是，不是每一个人都能做到坚持。那我觉得这个坚持是非常重要的啊。我原来就有一个学生，我就觉得他是已经很好，就是上高中的时候，你看不出来他有什么很特别的、很怎么样的，但是呢，他就一直不努力，也就是一直没有放弃啊，去努力学习。我觉得大学下来也是挺不错的。然后呢，我还有这个同学是去现在他 college 读 computer science，然后呢，这个现在在那个 library 那个工作，然后呢算是政府员工，因为你知道 library 我们算是事业编嘛，然后呢所以他是有阳光工资，然后呢有这个享受政府福利和津贴的啊。那么你看他呢仅是一个 Seneca 这个 college 毕业的啊，对，但是他的那个 computer science 学的是非常扎实，所以说 computer science 呢就是说，他的那个就是编程能力是非常强的。对，所以这个是很重要的。我觉得最后，我们这个关于计算机这方面，还是强调的一个是动手能力，就是你动手能力强的话，其实哪里都挺好。
好，那么现在啊，
都来的差不多了吧？还有谁？
都来了。好了，那么差不多了的话，我们差不多就开始上课，好吧？那么一样的我们再briefly review yesterday's lecture. So yeah, yesterday we talked about the last bit of functions, and the first was the scope of the function, right? In the scope of function, there is like the idea of local variable, there is the idea of global variable, right? And the local variable is just the variable inside of a function, and the global variable is it is outside of any function, right? And you can think of function as a temporary room, and global environment is just sort of like a house, right? And then yeah, the Python, there are 3 helper functions. They are called locals, globals, and vars. And the vars are just used for an object. If you don't pass into any parameters, then vars are just the same as locals. Okay. And the difference between locals and globals, locals just get the current variable dictionary, right? And then if you put locals inside of a function, then it is locals. But if you run outside of any function, then it is globals. Okay. And the second one, no matter where you run globals, then it will always look for global variables. So that is the same. Okay, and we have this large code box for testing. So for example, here x is equal to 5, and then you call tests, and then age is equal to 20, print age, then gives you 20, print locals, then that will give you a dictionary with only age, right? And so this is age and then 20. And then you can access the value of variable using this dictionary, right? So you call locals and then square bracket, and then do age, and then it will give you this. And then if you try to reset or change the value of a local variable using this locals method, that will not work, right? Um, like here, if you print out x age again, then this is still 20. This is not being changed to 12, okay? But for globals, this can work. So you can have x and z, and then equal to 21, equal to 19, and equal to 21. Okay, and then so the value of x and y, z has changed. If you print globals, there is in this one there is a whole large line here. Oops, sorry about that. Yeah, if you scroll all the way to the end, you can see here x is equal to 19, z is equal to 21, y is equal to 20. Okay, so that is what happened. And if you put here locals, this is the same as globals, because these locals are outside of any function. Okay, and yeah, you can print x. X in this case will be just 19, and then you can access or change the variable using this globals, and then you can also change this using locals. Yeah, so the only time changing variable with locals does not work is when you're trying to change it inside of a function. Okay, so that is the case. All right, so here a name is equal to Charlie, and then you define a test, and then if you try to have the same variable here, that will work. Oops. If you have this, and then that will work, but that will only change the name here, right? So it is only dealing with this logo. It does not see this name Charlie over there. But if you want to, sort of print out, if you sort of wants to print out Charlie in this function, and then define this name, and then print out this, then it will not work, because it is saying that a local variable name referred before assignment. Okay, so before you actually assign a name, this is already in use. Okay, so yeah, because the reason why this is not being used, because those are not global, and inside of a function this global variable cannot be seen. Okay, all right, so this is this, And if you really want to change, or you really want to access, if you really want to access those using you can use the function globals, right? And if you use globals, then you can use the square bracket notation, and then you can access it. And what you can also do is just to declare this name is a global variable, right? So you can use global name, and then you just do print and function, and then print name. It will be print Charlie will be printed, and then name is changed back to Ray, and then you print name, then it will equal to Ray. Okay. So that is that. We also have talked about local function, right? Local function has the idea of it is a function inside of a function, right? And so in this case, get mass function and then blah, 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 a bunch of parameters, and then you define three functions here. And then if type is equal to something, you just return um, the value of the result of that function, right? So you call return square with a parameter, and then it calls square, and then the square returns n times n. Then it is again returned to the main to this get mass function, which gives you 9. And then the same works for like the cube or get mass function. Okay, so in here, this sort of works like the same. You have a function. If you want to access the variable in the outer function, this does not work if you simply do something like this. Okay, but there is a way. So similar as global, then we have this non-local, right? And the non-local name means just I'm declaring this variable, okay? So this is the same as this as I am talking about. So you can print name, and then you can change this, and then after you have changed it, then okay, yeah, I have not run this, but yeah, okay, yeah. So after I have changed this, I print it out. Then I print out this name here, and this is not affected. Okay. And yeah, so this is a corresponding keyword as like similar to global. All right. Yeah. So advanced function techniques. In Python, a function can be a variable, or functions are a function object. You can assign an object to a variable just like assigning int, floats, or list, or etc. Right? And you can, as you can see here, we are defining a function called power, and then you do my function equal to power. Right now, my function has right now my function is a function as well. If you get the type of that, you can have a class function, and then if you can print it out with like two numbers calling it, then 3 to the power 4 gives you 81, right? And then if you have defined another function called area, then you can assign that, and then you can call it again, then it will give you 12. Okay, so that is assigning a function to a variable. After you can do that, you can really use function as a parameter or a return value. Okay, so what you can do is this: you have a bunch of data, and then there's a function called mapping. Basically means that you know, this data here. So as you can see, those all four functions are parallel, right? This means that like not any one of the function are nested. So you can actually pass in a function, right? You have square, cube, and factorial, and then you're just doing calling a function called mapping, and then you pass in the data. You pass in a function that is handling that data, and then this mapping function will do that function for each of the data, right? And then if you print that, then this result is given. And then if you do type mapping, it is still a function, right? Okay. So the next one will be use function as return value, right? You have those. Those are function inside of a function, right? And then you're specifying a type, right? And then so I can call this get mass function with parameter as cube, right? And then this ideally this get mass function will throw me a cube function. Then I will use that for my mass function. And then if I call mass function bracket 5, then 5 will be put into 5 will execute cube, right? Yeah, so, and then you just update it with square, update it with some other, and then, you know, uh, this square is passed in, this factorial function is passed in as well. Okay, so that is return value. Lambda expression, you can have this sometimes. Sometimes like when a function is actually inside of a function, no one else can actually see what is inside of the function except that function itself. So sometimes you do not even need a time, right? You do not even need not time, but like you do not even need a name. Sorry about that. You don't even need a name. So you can use lambda expression, right? Lambda expression is just a short way of defining a function and use it really rapidly. Okay, and it is, since it is only for one line, it does not it cannot actually do too complicated stuff. But yeah, if you have like a really simple function and then you just want to implement it using lambda, like go ahead. Okay, so that is that. Yeah, so the syntax for lambda is basically you have the keyword called lambda, and then you have the input values, which is parameters, right? And you can have as many parameters as you want, right? And then you have a colon, right? And then after the colon, you just sort of give out the return value, which is in this case x times x. And then after that, you just we have a map function here. It needs a function and a iterable object. And then if you try to type in the class's map, and then if you print x, it does not work because it only tells you where the object is. And you will have to do this for e in x. So you iterate through each object of the each instance of x, and then you just put it into a list. Okay, and then this is what the outcome is. Okay, and then you have another another variable here, another map. You can this is basically the same, but you can also add a if else statement. So if so yeah, it is making the lambda function a little bit complicated, but not that complicated because it is still one line of the one line sentence. Okay, so yeah, that is that. Yeah, so here comes the exercise. Okay, has anyone tried the exercise, or like if there is anyone that wants to share or anything like that? Yeah, any problem before I actually go through it? All right. Okay. Okay. All right. I guess I will just go ahead and show you my solution. So for this function factor, okay, what happened is you have to write a function factor to print all factors of a given value. Okay, and so, for example, you have a input, right, and then you are just gonna return a list of factors. How do we do that? I think we have tried it yesterday, but not too much. And so my solution is for I in range. So you have to be careful with the range because it starts from A. If you start from 0, then you will have a division by 0 or like mod by 0 error. Okay, so what is this here? So this means that what is this expression? This expression means that I am taking the square root of this value and then change that into a integer and then I plus 1. And the plus 1, the reason for that is, in Python, the range function on the right of the index, it does not include, right? So you sometimes have to add the 1 so that it makes the loop contains the last value that you want to loop on. Okay, and why is this value multiplied by 0.5, which is the square root? And the reason why is, think about that. If you have a number, right, and you're trying to loop through it, and you try to find the factor of that. So you starting loop from 1, right? And then you start looping and looping. When is the good termination point, right? And you might say that, if how large is the number, then I will loop how many times, right? And yeah, I mean, that is valid. This is okay, an okay solution, but that means that um, the number of times that you run is directly depend on what's the value, or you could say is the same as the value, right? And basically you're just counting from 1 to value, and then hope for a break, hope for there is the solution. But what you can also do is, for example, I'll give you an example. I will draw it out here. Think about this. We have number 1. Why is it green? Okay, make it red. 1, 2, 3, 4, 5, right? 6, 7, 8, 9, 10. Yeah, so what happened is um, you're trying to loop through it, right? And for example, in this case, it will be 10. But you know, you can only loop. The idea is you can only loop through the square root of 10. And what that means, this is because that square root of 10 times square root of 10 is equal to 10. Is that correct? Right? That's definitely correct, right? The square root of 10 times square root of 10 is just 10 to the 1, 10 to the half, and then square it. So it's just 10. And using this as a indicator, so square root of 10, I believe, is 3 point something, right? And the conclusion is that you only have to loop through those 3 numbers. And the reason why is if you, well, if you do, 10 mod 1, it will give you 0, right? And then if you do 10 divided by 1, it will give you 10, right? So every time you loop, you will get two answers, right? And then both of them are factors of 10, factors of this value, and then this value in this case is 10, right? And then now you try to loop this. And then for number 2, then you will have, okay, 10 mod 2 is equal to 0, and then 10 divided by 2 is equal to 5, right? So that is it. And then if you mod 3, then it is not equal to 0, because you can the answer is 3, and then there's 1 left, right? So this is the idea, that you only have to loop until the square root of that value, because when you loop until the square root of value, then you will automatically find out all the rest, right? Because you have 1, then you divide it by 1, then you'll get 10. If you have 2, you divide it by 5, you divide it by 2, you get 5, right? And then after 3, okay, so what happens after 3, right? And if you want to check 4, no outcome. If you want to check 5, then okay, 5 is already in the list, right? So you do not have to check it. All right, check 6, no results. 7, no result. 8, no result. 9, no result. And then 10, or 10 can always be divided by itself, or mod by itself, right? So that is that. And then conversion of int. So I would say that I will make a comment here that if you only loop to int and then value times 0.5, then it will probably give you a smaller number than it should be, right? So you will have to check until this number here, which is so yeah, if you have value times 0.5, then you'll get like square root of 10, right? And then square root of 10, if you convert it into an int, then it will probably be 3, right? And then if you plus 1, then the range will be like number here, And then in Python, if the ending index is here, you only check from the front to the index before, this this value, right? So that is the reason why I have to add 1, because if you don't, then you can only check to 2, and then 3 could be a valid valid pair of factors. Okay, so yeah, I'll clear my drawings. So yeah, the idea is that this factor always come with pairs, right? And then if you get one of them, you can get the other. And then because I give you a hint already in the question. So the consecutive 2 values are actually multiplies. If you multiply them, it will get 10. You'll get 10. So you'll get the answer. All right. So our trifactor of 20, and then that turns out pretty nice. So we have 120. You have 2 10. You have 4 5. Right. So imagine if I don't have this 4 5. Oh, if I don't have this plus 1, right? So if you do square root of 20, it will be 4 point something, right? The way I calculated is 4 square is 16, 5 square is 25, and then square root of 20 is just definitely somewhere between there, right? 4 and 5, right? But the loop condition is that if I do this, then the range is only from 1 to 4. Range is basically like 1 comma 4, right? And then 1 comma 4 only checks 1 2 3, and then it does not check 4. So the solution 4 5 does not exist there. So this is not what we want. We want a efficient way to check, but without missing any answers, right? So yeah, if you add 1, that works. Okay. So that is that, and the rest of it is pretty easy. Instead of append 1 single time, you append twice, right? So you have 120, 210, and then 4 5. Okay, so that is that. Is there any kind of question on this exercise? Is there anything that you do not understand, or is there anything that you're feeling right now? Speak it out loud. I mean, I suspect that most of you guys, if you have done this exercise, then most of you guys will actually loop until the value plus 1, right? I'm suspecting, but I'm not sure, because when I first see this question, I do something like this as well. Okay. All right. So nobody really wants to talk. Okay. For sure. So that is that. This Fahrenheit, this convert to Fahrenheit is easy. You just have to search for the formula. The formula is Celsius multiplied by time, multiplied by 9, divided by 5, and then plus 32, right? And then you just put in those 3 test cases, 0, 32, and then 100. Then this can be solved. Okay. Yeah. So the other exercise is a sort a list of string by the third character of each string using a lambda function. Okay, so then I have this sample string here, and then I sort I sorted with using a keyword called key, and then keyword. This key is just a function that sort of how you approach this data or how you prepare to sort it, right? And then in this here, I passed in the lambda function, which is only get the third index of that, you know, get the third index of the string, right? And then you just somehow sort that, right? And then yeah, okay. So you just print it out, and then as you can see here, the third character here is A, so A will be the first, P will be the second, R will be the third, and then T will be the last, right? So yeah, that makes sense, and that sort of solves the problem. Okay, is there any questions on this? I will give you guys like 5-minute break slash Q&A period for whatever we have talked about. And also feel free to ask questions if you have any questions. Feel free to ask questions about the assignment, right? And it is for those of you who needs credit, it is ending the end of today, right? So you have to sort of hand that in before the end of deadline. And if there is any questions, here is the time to ask. You can chat me in private, and or if you want to talk in public, then it is okay. Then if there is any specific questions, I will elaborate more on the assignment. Okay. Oh yeah. For those of you who don't need the credit, I mean the assignment is there. It is good for you to do it, but it is not required. And if you have any questions or you want me just to take a look at, then you can send it to me as well. Okay, I am pretty flexible on that. So yeah, I am happy to take a look at your code and see if there is anything wrong with it. All right. So that is that. And the way you hand in, you just go to the Discord chat, and then you can just give me the link. You guys know how to share the notebook, right? So you just do share. It's waiting. So yeah, you can change the you can change this, but usually I use commenter, so I would recommend use commenter, and then you just copy the link and send it to me. Okay, so that is that. All right, you have 2 more minutes. We will wait until 45 and then begin today's lecture material. All right. All right, so we will actually begin today's lecture. Today we are gonna talk about class and class and methods. So object-oriented programming. Yay! So yeah, I will show you a good link for this object-oriented programming. So yeah, it just briefly introduce you. Yeah, so that is something that you need to know.
A popular interview question concerns the four core concepts in object-oriented programming. These concepts are encapsulation, abstraction, inheritance, and polymorphism. Let's look at each of these concepts. Before object-oriented programming, we had procedural programming that divided a program into a set of functions. So we have data stored in a bunch of variables and functions that operate on the data. This style of programming is very simple and straightforward. Often it's what you will learn as part of your first programming subject at a university. But as your programs grow, you will end up with a bunch of functions that are all over the place. You might find yourself copying and pasting lines of code over and over. You make a change to one function, and then several other functions break. That's what we call spaghetti code. There is so much interdependency between all these functions, it becomes problematic. Object-oriented programming came to solve this problem. In object-oriented programming, we combine a group of related variables and functions into a unit. We call that unit an object. We refer to these variables as properties and the functions as methods. Here's an example. Think of a car. A car is an object with properties such as make, model, and color, and methods like start, stop, and move. Now you might say, but Mosh, we don't have cars in our programs. Give me a real programming example. Okay, think of the local storage object in your browsers. Every browser has a local storage object that allows you to store data locally. This local storage object has a property like length, which returns the number of objects in the storage, and methods like set item and remove item. So in object-oriented programming, we group related variables and functions that operate on them into objects. And this is what we call encapsulation. Let me show you an example of this in action. So here we have three variables: base salary, overtime, and rate. Below these, we have a function to calculate the wage for an employee. We refer to this kind of implementation as procedural. So we have variables on one side and functions on the other side. They are decoupled.
Yeah, I'll just make a comment here. This is JavaScript code, but if you know how to read Python, then this is pretty similar. But yeah, just don't mix them. Okay. Yeah. So those are just defining variables. This is a function. You pass in a bunch of those, and then you have a return. Okay.
Take a look at the object-oriented way to solve this problem. We can have an employee object with three properties: base salary, overtime, and rate, and a method called getWage. Now, why is this better? Well, first of all, look at the getWage function. This function has no parameters. In contrast, in a procedural example, our getWage function has 3 parameters. The reason in this implementation we don't have any parameters is because all these parameters are actually modeled as properties of this object. All these properties and the getWage function, they're highly related, so they're part of one unit. So one of the symptoms of procedural code is functions with so many parameters. When you write code in an object-oriented way, your functions end up having fewer and fewer parameters. As Uncle Bob says, the best functions are those with no parameters. The fewer the number of parameters, the easier it is to use and maintain that function. So that's encapsulation. Now let's look at abstraction. Think of a DVD player as an object. This DVD player has a complex logic board on the inside and a few buttons on the outside that you interact with. You simply press the play button and you don't care what happens on the inside. All that complexity is hidden from you. This is abstraction in practice. We can use the same technique in our objects. So we can hide some of the properties and methods from the outside, and this gives us a couple of benefits. First is that we'll make the interface of those objects simpler. Using and understanding an object with a few properties and methods is easier than an object with several properties and methods. The second benefit is that it helps us reduce the impact of change. Let's imagine that tomorrow we change these inner or private methods. None of these changes will leak to the outside because we don't have any code that touches these methods outside of their containing object. We may delete a method or change its parameters, but none of these changes will impact the rest of the application's code. So, with abstraction, we reduce the impact of change. Now, the third core concept in object-oriented programming, inheritance. Inheritance is a mechanism that allows you to eliminate redundant code. Here's an example. Think of HTML elements like text boxes, drop-down lists, checkboxes, and so on. All these elements have a few things in common. They should have properties like hidden and inner HTML and methods like click and focus. Instead of redefining all these properties and methods for every type of HTML element, we can define them once in a generic object, call it HTML element, and have other objects inherit these properties and methods. So inheritance helps us eliminate redundant code. And finally, polymorphism. Poly means many, morph means form. So polymorphism means many forms. In object-oriented programming, polymorphism is a technique that allows you to get rid of long if and else or switch and case statements. So back to our HTML elements example, all these objects should have the ability to be rendered on a page. But the way each element is rendered is different from the others. If we want to render multiple HTML elements in a procedural way, our code would probably look like this. But with object orientation, we can implement a render method in each of these objects, and the render method will behave differently depending on the type of the object we are referencing. So we can get rid of this nasty switch and case and use one line of code like this. You will see that later in the course. So here are the benefits of object-oriented programming. Using encapsulation, we group related variables and functions together, and this way we can reduce complexity. Now we can reuse these objects in different parts of a program or in different programs. With abstraction, we hide the details and the complexity and show only the essentials. This technique reduces complexity and also isolates the impact of changes in the code. With inheritance, we can eliminate redundant code, and with polymorphism, we can refactor ugly switch case statements. Well, hello, it's me, Mosh, again. I wanted to say thank you very much for watching this tutorial to the end. I hope you learned a
Yeah, so that was the 4 pillars that in the object-oriented world actually be interviewed with this question as well. So this is something that is really helpful. if you want to focus more on the object-oriented side in the future, yeah, so just be aware of that. Okay. So after this short video, let's actually start on today's lecture. So define a class. Class and object, right? And the difference between the class and object is that, you know, the class is a class, right? So class 呢是一个类，比如说是一个类别，比如说你说车是一个类别，猫猫狗狗都是一个类别，人也是一个类别。那么 object 是什么呢？那 object 或者是 instance 是一个类的实例，比如说你是一个人，对吧？那边有一条狗是狗的类比，对吧？那边有一只猫是猫的类比，那边有一辆车是车的类比。那么就是说，you can define a class, right? But there is a actual instance of that class. Right, so object means that this is a actual instance of this class, and 类中定义的方法默认是实例方法，就是说 this is instant method, and the way you define an instance method is the same as defining just a simple a regular method, but only that the first parameter will bound it to self, right? And yeah, here, 就是说第一个参数会永远绑定到self，也就是自己。那么这个自己的 idea 呢当然了，这边也有写，说是你不需要一定说是用 self 来定义这个 parameter name，但是说呢，这是最 make sense 的，然后这个也是use as a convention， so it's better just keep that way。 OK， 那么就是说 self right and then oops 这边下划线没有打出来那这样对，这是实例方法。实例方法的意思呢，也就是说我有一个实例，然后我会去靠这个方法，对吧？就比如说你可以找到一个相像的方法，比如说list 点 sort， 对吧？你 list 点 sort 的时候呢，你是拿一个真正的 list， 比如说你这个oops let me get a code box. So we have a list like this. Li is equal to like 1, 2, 3, 4, 5, right? Maybe 9, 5, right? And then call li dot sort. And then you're sort of just print li, right? So you call li dot sort instead of like sort, instead of sort dot li, right? I mean, if you try to run this, then the name sort is not defined. Yeah, the name sort is not defined, right? And it does not know what sort of class that you're talking about, right? So you have to use an instance to call that, right? And then you might, if you pass in li, yeah, sort takes no positional argument, right? So the only way that you can actually call this method is sorry 抱歉，我接一个电话，马上就好。 OK，我们继续。好，那么这个就是一个 instance，也就是说一个实例方法。那么我们现在举一个例子。We have a class called person, right? And then this is a class field, or this is a variable in the class, right? And then you can just use that as a variable, a specific variable in the class. And there is in Python function like this. So 你可以看到这边有两个下划线，你看一个两个，对吧？一个两个下划线。那么这些方法呢，就是这些 method 呢，都是有实际作用的。然后这个双下划线呢，它是会有一个就是 convention，但是呢we'll talk about that later。OK，就是说它是一个特殊的方法，它不是一个就是怎么说呢，比较普通的，你想自己定义的。你比如说你这个是比较普通的自己定义的那种乱七八糟方法，对吧？那么这种普通的方法基本上是长这样。然后这个特殊方法呢，这个 init 方法是什么？怎么回事？就是说，when you try to call a function，when you try to establish or when you try to get a instance of the class, you would say p equals to person, with person is just a class name, and then you directly add the brackets. Okay, and what does that mean? So it means that you're actually making a new instance out of that class. OK，就是说你创建了这个类的一个对象，OK，或者说是一个 object，对吧？object 不是都叫对象嘛，对吧？然后当你创建这个对象的时候啊，这个方法，这个 init 方法就会 automatically be called。OK，就是说在你创建的时候，你其实是在靠这个方法，好吧？那么你其实在靠这个方法，它的作用是什么呢？它作用是它会绑定一个 self，它会绑定一个 self 函数。那这个 self 呢，其实就是这个 object，OK，and then 这个 self 呢，其实就是这个 object p。那么你可以理解为 p，然后这个 object 呢 name 这个是 default value，对吧？在我们那个 function 的课里面也学过。This is like a default value, and then this is also like a default value, right? And then if you actually pass in parameters for name and for age, then oops, typo. Yeah, so if you actually pass in name and then actually pass in age, then you will just assign those two variables to the class field, right? Class field just means class variable, just means like a variable for that class, right? Remember that the idea of encapsulation. So like, a bunch of variable is bounded with this object, right? And yeah, so that is what happened when p is equal to person bracket bracket. So remember that every time you call a class with a bracket after it in Python, it means that you are making a new instance out of that class. Okay, and then if you print p name and then p age, then it automatically define it for you, right? And the other point is that you don't see those variables in this variable list, right? In the variable list, we only define hair, but you can add into more variables like this. Okay, so that is that. And you can change that name, right? P.name is equal to Li Gang, and you can say P.say, and then Python is easy to learn, right? And then it actually says it, and then the content is passed in, right? And then this self is automatically bound to this object. Okay, so that is something that you keep in mind. You don't want to ask, hey, this have two parameters, and when you're only passing in one, that this is not treated as position. This is not treated as the object itself, right? This is not treated as the first parameter. This is actually treated as the second parameter, and that reason why is because this self is automatically bound to this instance, right? And that is why it is called a instance method. You pass in this variable called self, or something else, but we will stick to that. But yeah, we're passing this variable called self, and then just do instance dot, this function name, this method name, I would say, because this is a class, it is for an object. We call it the method. Okay, so yeah, and then we will try to print p.name and then p.age. You can change the age as well, something like that. Yeah, let me define this class here. This class, this person, and then yeah, that's it, right? And that's basically it. So that's how you define a Python class. Okay, add a field to the object. So after you define it, you can add a field, right? When I mean a field, this means that just basically add a class variable, right? And then the class variable can be anything you want, right? And then you can do p.skills, right? Person.skills. This is basically saying that person, the skill variable of that person, right? You can assign it into a list. It does not matter in Python. So you can assign it to anything. But for now, we'll just keep keep it. So if I do this, then I can do print p skills, right? And then I can also delete a class field, and then I can delete p.name, and then I can still try to print p.name, and then the person object has no attribute name. Okay, so after I delete it, if I try to print it again, it will not say anything. Okay, and then yeah, after the second run, so because I run the entire code again, and Python is line by line, this is giving me an error because we have already deleted the function, the field name, and I am trying to delete it again. So yeah, what happens is I have to go through this and try to build it again. Okay, so you can delete something only once, because once you delete it, there is nothing there. Yeah, and also you can print out p skills, and you can see everything is still there. Okay, so that is how adding a variable and deleting a class variable. Okay, so what else? Since that we have learned advanced function techniques, you can know that the variable can be a function, right? And since because of that, it will be very easy of you to think of, I can add a variable to a specific object, right? And if can I do that for a method or a function as well, right? And so that's actually define a function like this. So we can define info and then bracket self, and then we can and that will sort of just print info function with a self in it. Yeah, so yeah, that is the info function. And then when you try to do that, p.info, p.full, this is just a random name, is equal to info. And then if you do p.full without passing in anything, it will give you an arrow. It says missing one required positional argument called self. Okay, so as I read the note here, Python 不会绑定方法自动绑定到第一个参数，就是会给后绑定的方法自动绑定到第一个参数。也就是说，if you add the class, like if you add this method after you define this class, right? What you will have to do is when you try to call this function, you will have to pass in yourself as well, okay? Because it will not automatically be bundled, okay? So you will have to call it yourself. And you can also do a lambda expression. You can sometimes that function is just easy enough or anything like that. You can just use a lambda function, right? And then the first input will be self, right? Just note that as well. And then print blah blah blah. But you still have to pass in the self yourself, because self yourself. Okay, yeah, that's fun. Yeah, because it is the compiler will not help you. You have to do it yourself. Okay, so that is that. And what you can do to this situation, or how you can deal with it, there is a package called types, and there is a method called method type, and then you are so if you can do something like this. So definition of a intro function means a self and a content, and then you just sort of print I am a person, my information is whatever content that you pass in. Okay, and then you can do from types import method type. We will talk about this more, but for now, just remember that if you have a package, then you're just doing something like from, right? And then if you want to import a specific thing or a specific class, think about this. This is also a class as well. Yeah, got it. So yeah. So p.info is equal to method type, and then you pass in this intro function, which is this function that you want to create a bound between this function and the caller of that function. And then you just pass in the function, pass in the caller, and then after that you can literally do the same thing as you usually do, which is directly call this function without passing into without passing self, but you can pass in content. And you can see here the messages: I am a person. Information is life is beautiful. Okay, so that is this bounding to the self argument. Okay, so yeah, another thing is that always bring self before trying to access a function and a variable. So what is this? I have defined another class called dog, and then you can do define jump, right? And then self, and then what you can do is print jumping or whatever, and then you can define another function called run, and then the function in there calls the jump function, right? And then it is printing out a message trying to run. Okay, so that is fun. But yeah, what I mean by this is if you do this, because sometimes you're just lazy, right? The jump function is right up there. You definitely know where to look for it. Class, right? Come on, class. Yeah, but if you try to run this piece of code, then you can see this error message called name jump is not defined, right? So it is sort of looking for this jump function, and it cannot be found. And at this point you might say, yo, stupid Python, do something useful. Right? But yeah, all you have to do is add a self to it. Right? So whenever you are trying to create a class variable, or a class, or you're calling a class method, always do like self dot jump. And what does self mean actually? Self means that when you have a instance that is calling this method, then self is just bounded to that instance, right? So this is basically the idea of, if you have an instance to call run, then what will happen is this instance will call jump, right? And then you're just print, yeah, and then after you've done that, you're basically done, right? So if I run this code, then you can see class.jump, and then you do d equals dog, and then d.run, right? And then this run function bounds this self to it, and then you do self again, right? So self.jump, right? So you're basically doing p.jump, d.jump. This case is dog instead of a person. So d.jump, d.jump gives you jumping, and then it's trying to printing out a message trying to run. So I can see it is trying hard. Okay, so yeah. Okay, so the idea is in constructor. So we can have also define a class for in constructor or whatever, and then there is a difference between this local variable and define variable and this variable, right? This class variable, right? So if you do self.full, then this is a class variable, and then if you try to print this out, then in constructor.full, then you can you can actually only get this number 6 instead of this number 0, right? And then this local variable is sort of the idea of you can only access it within this within this function. Okay, so yeah, that is the idea. And then the other another example in here is that you have a class that is a user, and then you do define a test, right? And then you have a self as the parameter, and then print self parameter is equal to self. Then you do u.user, so you initialize a user instance, right? And then if you call u.test, right, and then you just sort of like testing it, and then you have another thing called full dot equals u dot test, right? And what happens is the self object here is also carried in this assignment, right? So if you actually call this function full, right? As you can see, full is not an object, right? If you can, if you're curious, then you can print type to it. Sorry about that. If you're printed the type of full, then you can get this thing called class method, right? So this is a method because u.test is a method. But if you directly call this full function, then the object that you put is still there, right? And then as you can see here, the self parameter, and then this is like main user object at blah blah blah. And as you can see, this is the address, and those two addresses are still the same. So that is the way you can tell that this both of those are the same. Both of those objects are the same. Okay, so what you can also do is like this. We have a class called return self. Maybe we need better names, but who cares? Okay, so return self, right? So def grow. Grow means that we have a function that is called grow. We take self as a parameter, so that is a instance method. Can have this if has attribute self age, right? This has attribute just means that it takes the object, and it takes a field and see if the object has that field, right? And then if there is no such a field, if there is such a field, then this field is incremented, right? Else, if there's no such field, then you can assign this self.age is equal to 1. Okay, and then what you can do is return self, right? The return self means that you're passing back this object to whatever it was. So what happened here? So rs.grow, right? So what happened is you have a instance called rs, and then you call this method grow, right? And self.age is equal to 1 because originally there is no attribute called age, right? So the first pass is that self.age is equal to 1. And then this self is again returned, right? So every time you return something, then you replace the whole expression with that object, right? And in this case, the object is rs, right? So rs.grow, and then the return value for that is rs, right? And then since this thing is rs, then you can again do rs.grow, right? So this entire thing looks like rs.grow.grow, but because rs.grow returns rs, so rs.grow.grow is just rs.grow and then rs.grow. All right. Yeah, I am pretty much done with the serial calling. But like, yeah, if you call grow 3 times and then you sort of run it, then it just gives you number 3, right? And then if you can copy more and more and more, you just grow 13 years old. Okay. Yeah, there's actually people out there learning Python in 13 years, old. But yeah, that is not important for now. Yeah, so that is that. Here, this is called. So we're getting to the next topic, and it is called a method, right? So I mean, a class can also use a instance method. What that means is that, for example, here you can define full and then print full in global, and then you have bar is equal to 20. That's known. Then you have class bird, right? And then you actually define a function bird, the function full in here as well. So you print full in bird class, and then you can do bar is equal to 200, right? And then those one, if you call those, this just seems to be normal. You call a function called full, and then you access the variable bar, right? And what you can also do is this. So bird dot full, right? And then you just print this. Full is in bird class, and then you just access it bird dot bar, right? And then it just does something there as well. And then as you can see here, if I try to do this will not work, because full is missing a requiring positional argument self. But if I delete this, if I don't need any parameter, then this can work. You can use a class and call this function yourself before you actually creating an instance, right? Because in here there's no instance created. There is no bird bracket, right? But you can still call those functions or access those variable. Okay. So yeah, so to compare, if you have class user and then you can you define a walk with the bracket parameter self, and then you just do like print self and then walking slowly. And then what happens is here, so if you do, I'll explain it line by line. So if you do this will not work, because it is missing one positional argument called self. Okay, so that is what I demonstrated you in the last box. So this has no problem. You are just defining a object of user, right? And then what you can do here is user dot walk u. And what happened is that you call this method, right? And using a class, but you are actually passing in a self parameter, right? And in this case, self parameter is an instance of user class. But you can also call it like this, okay? And then you can what you can also do is you can pass in this, right? And this does not have to be a instance itself, right? And you can actually pass in a string, right? And then it actually, sort of turns out that no matter what you pass in, then you can still trigger this function, right? And then the comments down there is when a class wants to call its instance method, then self will not automatically be passed in. You will have to pass it in yourself, right? Like this idea here is that user.walk does not work. You will have to pass in whatever you want to pass in yourself, okay? And then run this and it works perfectly. So in here, we are gonna talk about different sort of method. There's one method called class method, and there is another method called status method. And yeah, so before I actually explain what those are, I will just go into the code, okay? And after I show you the code, it sort of explains what it does, right? So here, you have this new thing called at, right? And I will talk about it in detail in the next few code boxes. And yeah, so this class function, this class method is defined like this. So define, maybe a function fly, and CLS stands for class. And this class function automatically bound the class. Okay, so just CLS, and then if you define a function called fly, and then you do print class method fly with a CLS, and then you can actually see that this this thing class main bird, right? So yeah, that is what happens. And there is another idea called static method, and a static method does not bound to anything. You have to pass in whatever you need yourself, right? And this static method, you can look at this calling function, bird.fly, and then you does not pass in anything, then you still get bounded by this bird, right? And then this static method, you're doing like bird.info, blah, blah, blah. And then you actually create an instance of bird, and then you can use the same thing, right? And you, it does not matter which, whether it's a class to call this static method or whether it is an instance calling the static method, as long as you pass in the parameter that you want to pass in, then it works perfectly. Okay, so that is that for a class method in the static method. Sorry about that. There's a typo here. Static method. Okay, so that is class method and static method. And this here, let me actually make this larger. This here is called a function decorator. And as you can see here, this at thing is a function decorator. Okay, this static method is also a function decorator. And I will introduce you guys what does those means with a shorter or easier example. Okay, so you have this function a, right? And then you just define a function, and then you have print a, and then you're doing something in this function a as well, and then you are taking in a function and try to execute that function in this function a. And then you have a function decorator, which is at function a, and then you have a def function b, and then you just do return b, and then that is the structure of that. And then this calling method is called, I try to print function b, and then I did not do this. Okay, and in fact, this is not callable. And when I do this, I do print function b. And this here is the same as a function a bracket function b. Okay, what does that actually mean? So function b is sort of used as a parameter here. Okay, so you're passing in this to here, and then to use as a parameter, and then you're putting into this function, and then you're executing function a. But function a is saying that print a first. Okay, so it prints a, and then execute whatever function that is passed in. Okay, so I execute. I have a print b, so I print out b, right? And then return crazy IT or whatever you want to return, right? And then this return is replaced. Function b is replaced by this return value. Okay, and then if you try to print function b, then this will give you this. So this is whatever is returned. If you print it, and that's that. So this is a function decorator. Okay, so it is sort of like you're decorating one function with another function, right? And and a more complicated example can be found here. So a more complicated example for a function decorator is that you have a function called full, and then you take in a function, right? And then you have another function in here, bar, and then you see here args. You're passing in a bunch of arguments, and then you just literally print. This is the same. This is the argument. This is the first, and then you just print the arguments, and then you just get one of the arguments, and then you sort of print it out this again, and then you print function.name, right? So what is the name? That is the function that is passed in, right? And then you can do function with parameter n times n minus 1, right? And then you can print 15 stars, and then you just return this function as well. And then you're sort of gonna return bar. So I will I will separate it using one line break so that you guys know that, you know, bar function is actually returning this function, and then the full is actually return bar. Okay, so this is a little more complicated, and yeah, so here you have a function decorator called full, and then you have a thing called my test, and then you take in one parameter, and then you're just printing my test comma a, and then you're just printing my test. Okay, so that is that. And then finally, when you try to call this function, my test 10, what happened is that you know, my function is been replaced by the return value of full bracket my test. Okay, so what happened? So you have a my function, you have a my test, and then you know, you pass in this function, and you're sort of returning a bar, and then you just go ahead and call that. So right now my test has this function called my test is equivalent to function bar, right? And then this function bar is trying to print something, okay? And then parameter 10 is actually passed into this thing called args. And, you know, args is just, you remember there is a star in front of it. So it is like argument collection, right? The argument collection, which makes this into a tuple. And then you just sort of print that out. So that is this outcome. Okay, so right, and then n is equal to args 0, so that takes the first element, which in here is 10. Then you know, you're taking in 10, and then 10 times 10 minus 1 is 9, so 90 is the second one. And then you print function dot name. Huh. Yeah, and then this function dot name is actually this function. So my test. Okay, so my test here is this function dot name, and then you sort of calculate it. You know, you do function with a parameter n times n minus 1, right? And then this is further, you know, this is then passed with 90, right? And then this function, this is basically, say, calling function bracket 90. So we go back here because this function is actually this my test. Okay, so we print my test, you know, a, right? A is passed in by 90, so you just do 90, and then print my test, right? So my test is what? My test is actually the value of function full dot locals dot bar at blah blah blah. So this is actually this function, and then after this execution is being done, it will return back here. And then you do a little bit of print, right? So print 15 stars. This is 15 stars. Okay. And then you once again return this. Okay. So you once again return this. So the bar is the return type for bar is, you know, another function call to this function n times n minus 1. So once again, you see two of this line is pretty much the same as those two lines. Okay, so that is what happening. That is a pretty complicated example. Yeah, so if I try to do this, it is basically doing a similar thing. It does not actually care the second parameter because n is only equal to the 0th argument. Okay, so that is that, and I am pretty sure that you will need more time to take this in. Okay, so yeah. All right. Next little code piece. So class namespace. So we have this class item, and then without doing anything, without executing a function, without having any kind of variable, you just do print, right? Defining an item class, and then you have this for I in range 10, and then you print even, you print odd, and then this actually executes. Okay, so this class namespace is just another namespace. You can still write normal code in it, but it's just that normally people does not do it. But yeah, this is this means that you can still write code, and you can also do something like this, right? So you can have a class and then category, and then you can actually use a lambda to define a function, right? Even though it seems like it is a variable, right? And then after you execute it, then this will make a difference, right? And you have a global function called function, and then you have this lambda function, and then you are defining another lambda function in this class. When this gets executed, then you can call the global function with a parameter, right? Then it can actually define an instance of this class, and then you just call an instance, right? And then it can actually run this method. Yep. So that is it for today's lecture materials, and I will briefly go through this exercise. This exercise is pretty simple. I did not actually include the decorator function decorator. I think that is the most challenging part of this lecture. So yeah, I would just let you guys to slowly take in and get the idea of how does function decorator works. Okay, and yeah, so the exercise, write a Python class who is named a student with two attributes, student name and marks, right? And then modify the attribute values of the set class, attribute value of the set class, and print the original and modified value of set attributes. Yeah, so yeah, so what basically means is that you're trying to, you create a class, right? And then you have two attributes. And then, you can have a function to print those two argument attributes. And then you can have a function to modify the value of those arguments. Okay, so that's that. So like maybe you can think of like a function called like change name, or update marks with whatever it is. Okay, and then yeah, create a vehicle class with max speed and blah blah blah. So that is another easy one. Just gonna make oops, what the heck? Okay, I'm just gonna delete all those. Okay, yeah, you can just get familiar with this class creation. Okay, and then similar thing, you can define a website class which you need to pass in the URL and the title to construct. Define a method that can display the URL and the website title, right? And then define a method that you can modify the URL. So yeah, that is more or less the same, and that is what you need to know and what you need to construct, get used to, constructing a class, or try to make some method. Sometimes the class and by the way, all of those methods are just instance method, so you will sort of have to pass in a self. Okay, so that is that for today's exercise. And then yeah, if there is any problem, I am opening up for a Q&A period. Yeah, are there any questions to this lecture overall, or are there any questions to assignments? Here's the time to ask. Yeah, and I will wait until probably 55, and then if there is no questions, then yeah, maybe we can call it a day 5 minutes before the actual time, because it's Friday, and then you guys deserve 5 minutes break or 5 minutes early end of the lecture. Okay, so I'm gonna wait until like 55, and then if there is any kind of questions, I am here to answer you guys. You can also try to start to do the exercises. Those I believe are not difficult. This is pretty similar to how will you post the class recording for today's session. So what I will do is I will just post a Dropbox link. You can use that link to download. And I don't know that if that is okay to Jennifer. Rewatch the recording after. Yeah.
哎，是这样子的，这个对我发现上传呢，它需要审核的时间太长了。因为我打算放在 YouTube， 我不想放在 B 站了。然后呢，YouTube 这边审核的时间呢就很长。那么我现在是个15号的和14号视频，现在放在那儿，它都说正在审核当中，正在这个 review 啊。然后呢，所以我不知道他们什么时候能长。那这样子，这视频的话，那也可能就是说咱们自己这个 Dropbox 可能是自己的学生，然后呢看一下，对。
好。
其他的概不外传啊。
好的，那这样吧，反正就是上传到 Dropbox， 或者上传到 Google Drive， 算了 Dropbox 吧。我这边 Dropbox 比较方便，或者说就是那个 Google Drive 可能有些那个也比较大。
然后另外那个是这样子，就是那个 Dropbox 当中呢，我这边是查了一下记录，我这里是显示的，因为我下载下来的，然后呢是有的，我这里已经有个标志，但是我缺2天的啊，然后我下载的呢，我已经在那个表格里面分享，就是之前我申请那个名单，我分享给你了，告诉我哪些是 download 的，但是有些是我不知道是什么原因，就是说可能我 miss 掉你的信息了啊，反正是我没有，所以你呢这边方便的话，你把一些这个链接，然后你发给我。
OK， 好的。 OK，没问题。好，对，那这就基本上就是这个 sharing 的部分。
对，然后给他们学生发链接的时候，不要发到 Discord，因为 Discord 呢，他们所有人都能看到。然后呢，这个我打算把这个 Classroom lock 一下，然后就是锁掉。锁掉的话，就只有自己的学生，然后能看到。
好的。那行，反正如果有什么或者有些特别想要的话，你可以
单独跟你联系，
私聊我，对，直接 Discord 上 direct message 私聊我，然后我把那个 class recording 发给你，就可以了，好吧？
是，
那基本上就是这么一回事。OK。
看还有什么问题吗？其他同学？
还有什么问题吗？对，反正别忘记，如果有需要 credit 的同学，今天晚上那个 assignment is due 的，好吧？现在有什么问题的话可以问，然后下午的话，对，
这个我知道，肯定有同学不太懂或者没听明白的。其实这个并不重要，因为有一些人是从 zero 开始的嘛，然后你就可以问就好了，好吗？
对，有些，比如说怎么说呢？有些时候我讲的时候，怎么说呢？可能会 assume 一些东西，然后就是有意无意的 assume 一些东西，就我也不知道你们这个到底懂不懂，所以说，反正就是要给我一点反馈的话，那我可能比如说，我可能会讲更多的东西，对吧？
是的，我觉得是这个 read assume 的东西应该是大家是有一定的编程 concept 和概念的人，然后 total 是零的人，我相信他一定会听的是
可能会比较累。
对，因为之前那个另一个 read 他就是现在改成 private 了，1对1了啊。然后对，他就不参加大课了，因为他就感觉一个是用英文讲，他听不懂，然后呢，他1对1的话，他可以改成一个用中文讲了，
对，反正都对大家都好，可以。
对，所以你们有什么问题，你像老师现在讲完课之后呢，你们可以用中文去问问题，不一定说是用英文
没问题，反正
对，
反正你说白了就是怎么样把你讲懂了就行。
对，就是这样子。其实跟你讲一下，就是说为什么开始要用英文讲，是因为我们在加拿大，然后呢，我们面临的东西和后期你在大学学东西全是用英文，你要 get used to 这个是必须要适应的。然后呢，其他的呢是你比如说课下问问题，私下讨论，不代表着是我们就不可以说中文啊，是可以的啊。然后呢，我们用中文来问问题，这是没有什么问题。只是讲课我们更希望是大家是用英文去理解，是因为你怎么也要适应这个东西啊，就是怎么说呢？你要知道在加拿大，对啊，我相信瑞你也有很多的面试最近，对吧？你可以跟他们讲，你面试的时候，请问有中文面试吗？
没有，就是说实话，就是我之前碰到中国人跟我面试，但基本上就是就是比如说他读我名字嘛，因为我静豪嘛，然后他就Hello 静豪，然后接着用英文。
对呀，所以说这个对啊，因为我们就业之后是想在加拿大的话，那肯定我们要面临的，而且你们上大学习的所有的知识 concept， 我觉得特别是在这边上高中的同学，你应该有个想法，就是说，实际上我们有时候说句话，我们不可能完全用中文去说完了。然后呢，而且呢，你像瑞，我相信你用中文讲也讲的会不太地道，因为很多这个中文的一些这个专业性术语，实际上你也不知道计算机的专业术语。
对，可能还得就是找一下对应的这些东西。
对，你就比如说你今天讲的那个 class 和 object， 那么以及 OOP， 在中文当中是面向对象，对吧？然后 class 呢是讲类，然后呢 object 呢是讲对象啊。那么这个是它的叫计算机专业术语啊，就无论你是用我们一般在这边学的都是用英文学的，所以说我们在学了这个东西之后呢，还是以大家就是说还是英文你要习惯，必须是你要把它作为一个主流的这种沟通的这个语言和桥梁啊。
对，再主要是你想，这编程语言全都是外国人写的，你用英文去理解它，岂不是很好理解？
是的，其实我也可以分享一下，其实我原来学计算机语言的时候， 这个我们就发现，就是英文学的好的人相对来讲容易理解。就比如说我们一开始学，我们是有 print f， 就是学 C 语言 C 加加嘛。然后呢，打印输出的时候，实际上有一些很多的 scanf， 然后呢是 print， 然后实际上其实你翻译过来，不就是说是一个输入一个输出嘛？啊，实际上是一样的。还有 output、input 啊，当年还有些语言是学 input， 对吧？啊，但是呢，万变不离其宗，它的这个概念和 concept 以及 key 的这个 keywords 这个意思和思想 sentence structure 它都是一样的啊。但是那个 Python 呢，它好的地方其实我觉得就是还是后期的，它不仅仅能做系统，但它和 Java 不一样的地方就是它还可以做这个数据处理。就比如说你的 NumPy， 对不对 ？NumPy， 你像我们很多学生，他们读研究生的时候读这个数据处理，以及读这个商科，就现在都比较流行的这些，那么他们都学这个东西。实际上，就你到研究生也在学啊，就是你只要是涉及这些相关领域的啊，就数据性处理的啊，那么。对啊，所以说这门课就是为什么开，其实它真的也挺有用的，大家还是要扎扎实实的啊，这既能编程，它还能呢，对于你后期你如果真的是说你想我发现我编程不想了，我想转这个什么那个风投啊，我想转金融啊什么的，我想转一些这个其实这种就是电子商务类的。那么实际上是因为它主要涉及到电子类的、电子商务类的，就是我们有一个领域叫这个嘛，它实际上也是和计算机系统是相联系的。那么其中有一部分呢是叫数据处理。那么数据处理呢，你可以看一下，其实之前我跟我跟一些给同学也分享了一下那个网站，那个呢是专门是，你包括他们学那个，我相信滑铁卢那边以及那个你像皇后大学那边，我现在有学生在那读研究生哈，他呢也在学这个 NumPy。就他自己也在说，哎，老师，你这个其实这个 Python 真的是挺管用的啊。对，行，那这个所以说不论你是听的云里雾里的还是怎么样的，然后呢，有什么问题，然后老师这边瑞呢都挺好的，然后呢，我最好的是他可以用中文给你进行解答啊。然后呢，所以我请大家珍惜这个机会啊。然后呢，瑞呢也都是百忙之中的哈，然后呢又得去参加自己滑铁卢的学习啊，然后呢他还有滑铁卢强制性的要co-op实习是吧？我希望最后的时候我也希望瑞留一堂课，然后呢给大家灌输一下这个面试的分享一下，给大家分享一下计算机面试的一些技巧啊，然后呢到时候呢我相信咱们在座的同学，如果你在读大学的话啊，这些都是能用得到的啊。行，那是我今天要说的。你看其他同学有什么问题没？
对，看一下，我现在 chat 里面没有看到有什么问题。对，有什么问题开麦或者那个都可以。如果实在是没有什么的话，那么就周一见，好吧？
好的，那没问题，我们就 have a nice weekend 了。
Have a nice weekend。
啊，行啊，那行，那个链接你一会儿你看一下啊，然后呢我们一会儿再 double check 一下啊，谢谢。
好的，
好的，拜拜。
拜拜。